Hello, my name is Karthiban and my register number is URK23AI1014, and now I am going to explain experiment number 5, which is to use the RNN to find the car sales prediction and stock price prediction and time series prediction using RNN, which is recurrent neural network. First, let's see the time series prediction using RNN. First, we import necessary libraries, which is NumPy, TensorFlow, Keras, Minmax Scalar, and Matplotlib. Next, we load the synthetic time series data. Next, pre-process the data using Minmax Scalar, which reshapes the data into a column vector required by the scalar. Minmax Scalar scales all value between 0 and 1 for better RNN performance. Next, create input-output sequences, converts continuous time series data into supervised learning samples. X is previous sequence length, Y is next data point, uses the past 20 data points to predict the next one. Next, we split the training and test sets, 80% for training and 20% for testing. Next, reshapes data into 3D samples, time steps, and features, which is the required format for recurrent neural network. Next, we build the RNN model using sequential function, which is linear stack of layers. First, we add the simple RNN layer of 50 neurons with ReLU activation function and input shape, 20 time steps, and one with one feature, and a dense layer with one neuron that predicts one value, that is the next data point. Next, we compile the model with a Adam optimizer and a loss function, mean squared error and mean absolute error. Next, we train the model using 20 epochs and a batch size of 32. And next, we evaluate the model and visualize the model. We evaluate the model using mean squared and mean absolute error. Next, we visualize the results. Let's see the results. This is run on 20 epochs, and the test mean absolute error is 0.0237, and this is the time series prediction graph we got, which is the actual and the predicted values, which is really good. And next, we are going to implement the prediction for car sales data. First, we import the same libraries as of before. Next, we create a simple time series representing increasing sales. Next, we use the car sales data, which is the synthetic data, and we use the min-max scalar, which is to transform the data between 0 to 1, and using the reshape function, which optimizes the value to the for the required shape for the min-max scalar. Next, we create the same sequences as we created before in the time series prediction. Here we use a sequence length of 10, and we build the RNN model using sequential layer, which is a stack of layers. First layer which we use is simple RNN, which has 50 neurons with an activation function of value, and the and finally a dense layer which is one, which predicts the next value obviously. And we compile the model using Adam optimizer and the same loss function as before. Next, we train the model with 50 epochs and 16 batch size. We use much epochs to get a much better optimized value. Next, we evaluate the model and visualize the model. Let's see the output. The blue line represents actual sales, and the orange line represents the predicted sales, which is pretty good. Next, we are going to predict the stock price prediction using the recurrent neural network. Here we import Y-Finance. Y-Finance is a library for stock price data. Next, the ticker symbol is the company's stock symbol. Next, start date and the end date is the date for the starting and closing price of a company. and we use the stock data, which is a synthetic value. We used it as a random values which we obtained from the y-finance library. We use that data and we pre-process using min-max scalar, which ranges from 0 to 1. Next, we create a sequence length as of before. Here we use a sequence length of 60, which determines a past days which we use for the prediction. Next, we use that data and we reshape it into a format which is used for RNN, which is a 3D shape like we discussed before. And we feed that data into the RNN model and we use the sequential function for the stack of layers, and we add layers like simple RNN. The first simple RNN which has 50 neurons with the activations of ReLU. Second also the same, and third which is the final layer of dense with one neuron which is the output which we use to predict the next value of the data. Next we compile the model using Adam optimizer and the loss function of mean squared error, and then we train and evaluate the model using mean absolute error, and then we visualize the results. Let's see the results. We got a test mean absolute error of 0.0216. Next, this is the graph showing a stock price prediction for AAPL, which is Apple, using recurrent neural network. The graph shows the actual stock price and predicted stock price, which is pretty good. Thank you.